we're going to look at how to multiply powers that have the same base. So for example, we've talked about a power, and we've identified what its base and its exponents are. So now what happens if you have two powers that have the same base and different exponents? And can you multiply them? So in this case, we have 3 to the exponent 2 times 3 to the exponent 4. So do they have the same base? Well, the answer is yes, they do. Okay? And so what this actually means, if you were to expand it out, it actually means 3 times 3. Okay, so this is the first piece, times 3 times 3 times 3 times 3. Okay, so how many times is 3 being multiplied by itself? Well, it's actually multiplying by itself 6 times. So when it's multiplying by itself 6 times, that's 1, 2, 3, 4, 5, 6 times. Okay? So if we want to write this as a single power, the base hasn't changed. It's still 3 that's being multiplied multiple times. So the base is still 3. It's the exponents in this case that are being changed. So instead of having 2 and 4 as being our exponents, now we've got 6 as our exponent. So if I want to evaluate that in my calculator, I'm looking for the exponent button. And again, every calculator is slightly different. For me, my exponent button is going to be, it will look like this. Sometimes your exponent button might look like x to the y on your calculator, but each calculator is slightly different. So for me, I need to put in 3 to the exponent 6, and that pops out a final answer of 729. Okay. So if I take a look at the next example, I've got negative 2, that's my base, and it's multiplied by itself 4 times, and then that's times negative 2 times the exponent 2. So what this actually means is negative 2 times 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 negative 2. Okay? So in this case, I'm actually multiplying negative 2 6 times. Again, we got 1, 2, 3, 4, 5, 6. So my base in this instance is actually going to be, again, negative 2. And you'll note that the negative 2 is in brackets, and that's really important. And we'll explain that a little bit more next day. But the base is negative 2 in brackets, and the exponent here is actually 6. So if I do bracket negative 2, and then I do it to the exponent 6, that gives me positive 64. Okay. Um, Even if I have a fraction, I can still work with this. So as a fraction, I have 1/2 squared times 1/2 to the exponent 3. So this is the same as saying 1/2 squared times 1/2 squared times 1/2 squared times 1/2 squared times 1/2 squared. Okay, so again, in this instance, how many 1/2s are being multiplied? Okay, actually, let me go back because I've actually written that piece out incorrectly. So let me correct that piece. So if I go through and I fix this, it's not 1/2 squared, it's just 1/2 times 1/2 times 1/2 times 1/2. So let me correct that to avoid any error going forward. So this is actually 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Okay, so again, I'm multiplying 1/2, 1, 2, 3, 4, 5 times. So if that's indeed the case, then my base still is 1/2, but now my exponent is 5 times. So if I do 1/2 as a simplified expression, that's going to be, and I'll do it as a fraction, because when we have fractional exponents, the exponent is applied to both the numerator and the denominator. Okay? So if I do 1 to the exponent 5, I get 1. And if I do 2 to the exponent 5, I get 32. Okay, so 1 over 32. So as a general rule of thumb, what this actually means is you have a, so let's say we have same base. In this case, the base is a. Okay, and one is to the exponent m, and the other is to the exponent n, and they're being multiplied. Well, what this actually means is you have a to the exponent m plus n. Okay? So when you're multiplying powers, again, with the same base, that's the key. They have to have the same base. So in multiplying powers with the same base, you keep the base and you add the exponents. Okay? So the base stays the same and you multiply the exponents. And again, I mentioned to you that on your calculator, some calculators have the exponent button as y to the x or x to the y, and others have it like this upside down V symbol. Okay, and both will work just fine.